Exercise 327. Copying down the terms in the sequence. That's the current term. The next term is found by replacing out n with n plus 1. 2 raised to the n plus 1 is 2 to the n, and then one more copy of 2. N factorial, written down as n plus 1 factorial, is binomial n plus 1 times n factorial. All of this is being raised to the power 2. In the bottom, take your time, distribute out 2 onto n plus 1 to yield 2 times n and then 2 times 1, so 2n plus 2. So this is the same thing as 2 product n plus 1. Now that we know what 2 product n plus 1 is going to be, we're going to get a power of 2n plus 2. And we can do some algebra in our head and pull off 2 copies of the base. Good. So let's copy this guy over. Copy that guy. And then when we copy this guy, we'll write it down over here, but we'll write it down as the reciprocal. So this we'll put in the numerator. And the numerator we'll write as a denominator. And then this is the absolute value of the next term over the current term. Again, we don't have to worry about the absolutes because these are all positive valued. Okay, so let's look for any cancellations. And 2 to the n is being raised to the power 2 in the top and being raised to the power 2 in the bottom. The same goes for n factorial, power 2 in the top, power 2 in the bottom. So those go away. Let's see. After removing that, let's do easy stuff. We'll have 2n plus 2 quantity squared times 2n to the 2n. And then I'm going to take this guy and place it over this guy, but that's just 1. So then this guy, let's place it over this guy. And then we can separate out. We can place this underneath, and then we can see that'll give 1. So that goes away. Then we need to copy this guy down. Okay. And what we can do is we can factor off a 2 from everything. So distribute the power 2n to each factor. Do the same thing in the bottom, factor off a 2, distribute 2 to the n to the 2, and 2 to the n, distribute it to the binomial n plus 1. Good. So again, that's 1, and then all of this simplifies as that. All right. This is 1, and this we can manipulate Since we have a common power, we can quotient up the bases. And then we know that 2 times n is the same thing as n times 2. And n times 2, because they are powers, I can pull off the power 2 and bring it all the way to the outside. This pops up a lot. It looks challenging, but it's actually rather nice. When you take the denominator and write it as the numerator, write it as the denominator, you have computed the reciprocal. So this guy is equivalent to all of this. Now we copy over the power n, copy over the power 2. Power n followed by power 2. And for the same reason, we're able to bring that -1 out, all the way out, and attach it to the 2. So that with this scratch work, our rho computed as the limit of the absolute value of the quotient of the next term over the current term is the limit of this as n goes to infinity. And n plus 1 over n, let's write this out. So n plus 1 over n is 1 plus 1 over n. That's being raised to the n. And then all of that is being raised to the -2. By properties of limits, we can save raising to the power -2 to after computing the limit. And then this limit we can recognize is e. So this is e to the -2, and e to the -2 is less than 1. So with rho being strictly less than 1, we have that the series in problem 327 converges. And what did we do? We used the ratio test. Nice.